Hölgyeim és uraim, akkor térjünk vissza a programkódokhoz.
Ladies and gentlemen, I propose we move on to the next program. Christian Scheffer is going to be the next one. I am reminded by my analysis teacher of him. He spent 2 pages trying to prove a theorem, and then he said the rest of the 3 are basically self-evident. That is how Christian looks at program lines. He's a code auditor, one of the most important and most difficult parts of IT security. So don't be surprised if he puts up a slide and he says character 18 in line 28, self-evident that it's a fault. For him it is self-evident. Hello. Well, I've never had such a good introduction ever. It is indeed true that I'm a code auditor. I do hope that I'll be able to tell you new things about code audit. Basically, what security code review is basically, it's, if you wish, a bastard of software development. No one really likes it. No one really does it. Why? Because what we remember is code is, someone comes into, a code writer comes into the room, sits down in the corner, reading the lines, sometimes laughing, sometimes holding his head. But then there will be others where, it's a Hungarian example, for example, a code writer is basically, when the application is ready, we put it in, package it into a big zip, we send it to America where they have a software that we don't have the license for, and then they run it, and then we get back, several hundred pages long document, and we don't have any, we can't really touch it. Of course, code review can be something different also. We've said already that this is a quality assurance activity, and of course, where they actually do use it, I think it's completely trivial. I do use this word a lot. In a Linux kernel, in a Firefox, of course, you don't have code lines that at least one person or 2, 3, 4 did not read after it was written and before it went live. Despite this, there are security problems. In business applications, we very rarely use it. It's a white crow, white elephant, actually. It's because quality sometimes tends to be pushed into the background when it comes to IT applications. If you see how such an application is ordered, someone wants a new business application, they actually issue a call for tender, they mention all the features, and they want it as cheap as possible by tomorrow with all the features. And then we, the developer companies, of course, we think there's a lot of money in this. If we can really get hold of this, we will survive on the support part. And of course, we don't need to earn a lot of money on the software development. While we go beneath one another's prices, we take all these risks that we realize during development, and during the course of development, we have to really be cutting ourselves short. And in the end, we have something that actually passed all the benchmark tests, and it is in line with the agreement. But it didn't say that the code has to be good quality. Therefore, the code is not of good quality. Despite this, there are quite good tools to maintain this quality. Basically, they do not allow code to be recommitted. It doesn't read. The reviewer doesn't read complete files. He just reads certain changes. This is from Chromium. They read actually a readware developed by Google. So basically, what you have is someone writes a code segment. They upload it here, and then they invite reviewers. And all those people who review these are, of course, programmers themselves, which means, of course, we're not separating them like testers. Same people write the codes as the ones that read it. That way, knowledge actually also, every developer herself becomes more knowledgeable. And of course, then you need the same set of skills also. So you have this description. This comes from Issue Tracker. We don't start something for which there was no issue. We see the code, we see the explanation, the description. This is actually a new feature that has a security aspect to it, that's why I brought this. We can see the modified files. We have a new test case. Of course, we do have automated tests. And then, all those people who are reading this code then basically discuss this. They actually questioned whether we needed this or not, despite the fact that in the issue tracking system we had an issue that it had to be done. Despite this, someone remember what happens if this becomes a security problem? So they discuss it, they come to an agreement, and LGTM means looks good to me, I like it. So when everyone says LGTM, then the robot who actually reads this tries to commit this change, but he cannot commit the change because among the invitees there wasn't anybody who would actually be a supervisor for this, administrator for this code segment. If it's okay, then it is committed. This is another event. What you see here is what you see when you are reading the code. It's only the green part that is the change. We see the context, but it's only the change, the modification that is interesting for us. And for this one line of change, you actually have this debate generated. There are actually someone wants a proper type to be returned. So this is what happened when security was only in it. The purpose of review was not to improve quality, but if we start dealing with it, then there's three main avenues. The first of which is the most important is vulnerabilities research. Vulnerability research is basically we sit down, we look at the source code, and we seek vulnerabilities. And of course we will find some. This is a very famous case, happened this summer. MySQL on different platforms practically cannot authenticate. And if you try enough times with a bad password, it will let you in. And you don't actually have to try too many times. Every 256th time it will let you in. That created quite a hysteria, and it will give a lot of money for the next coming years to pen testers. The segment is here that is causing it. If we go through it, there is a mybool type in this source, which probably was introduced into MySQL 15 years ago, because C language does not have integers, so they thought they had to define it as a character. C standard thought that it's not good to be defined as a character, but it's not so easy to change it if you've done it once, so it's been there. This graph actually says if the password is good or not. It actually looks at the if the password is good, it will return a false if the password is correct. It works quite the other way around, so it actually allows that the memcmp, what is there in the middle is not so interesting. We actually got two passwords, we do something with it, and in the end we verify. memcmp actually is a built-in graph in C, and it says it will return a 0 if the two byte blocks it compares. If these are identical, it will return a 0, and if their content is not identical, it will be something different from 0. And the standard also says that the prefix of the number, the plus or minus, will depend on which block is larger. It goes byte to byte, it compares, and on the first difference, depending on which one is larger, it will be plus or minus what is returned. This is very good. However, this is an integer here, and that is character. And character is only from minus 127 to plus 127. Integer is larger. And therefore, if this memcmp returns something bigger, it will not fit into that. So we will only use the end of it, and it can be 0 even if the entire number was not 0. So what you have is you return the 0 without actually having the two blocks being identical, which means you let the user in. Who has seen this when I actually... Who saw the problem when they first saw the slide? You know, it was included, written there by the programmer, it was there, and it seems for years. memcmp is actually very interesting, we'll talk about it later. I wrote this test program which I didn't do anything, I just deleted stuff, and I tried to get warnings. There's this Clang, CLang, statical analysis, that actually looks for such bugs. Didn't find it, but there's another one, splint, secure program lint, which actually first said that the types are incompatible, that my bool is not compatible. So if the MySQL server developer would have ran this splint, they would not have known. They would, when it returns the types are incompatible, not switch off the warning, no, but instead what they would have written there in brackets, character. So it actually forces. So the bug remains, but it will remain silent. In real life, you might want to switch it. You might switch it off, but here we are. The main problem is that my bool is a character. Perhaps thinking that you are reserving or occupying less memory, and that might have been the case. It's not. It should be defined as an integer, not as a character. But if you cannot change that, if it is given and the code is written, and back then it was, then the real problem, the main problem, is that memcmp did not return a 0, because that's what the standard says. It will be identical if it returns a 0. I want it not to be identical because there is this negation included. So this is the condition, but that's not what I'm thinking. That is what I'm writing instead. Why am I writing that? Because that is the C style. Because these are completely identical, the same thing will happen. But if I return it in return, it's not true, and the one who wrote the code did not forgot this or didn't know this at all. And also this is a test program written by George Drake. It tries to decide if our platform is vulnerable. If we translate it with the same links that MySQL is done, it will tell us if our platform is vulnerable or not. It generates random numbers and it checks them, compares them with memcmp, and checks them. The return value, is it outside of the sector? It will see if there is going to be an overflow. And if there's an overflow, it will say we are vulnerable. And after many attempts it doesn't, then it say most probably everything is all right. That's good. However, there's a bug here. It doesn't work well, because if we look at this is what they are studying, when in fact this is what he wants to find out. What he wants to find out, does memcmp have a return value that is not 0, but if we force it into a character it is going to be 0, because that's a problem. Why isn't he writing this? God knows why, but probably because the original bug report that was done by Sergei Bubluchik, security coordinator at they found this bug in a security code review. They said that this is a precondition for being vulnerable. What is a precondition? If you studied analysis, I'm sure it was a problem for you always, that you basically have a you have an arrow pointing from bottom to up, which means that the top derives from the bottom, but it doesn't work the other way around, and that's not true here. If we looked at it from the bottom, we could say that the top was true, but if we looked at the top, we know that the bottom is not true. Here's a bit of assistance. I'd like to incite you to think. If anybody, don't shout, please put your hand up, and I have a helper here because a UB key will actually be the prize. The question is, how should I change this in order to actually have the equivalence being true? I give you an example here, that minus 29 is returned by MCMP, then when I force it into character, that becomes 127, which is not 0. So there is an example which is outside of this, but this is no longer true. So while you're thinking, I'll tell you why this is a problem. This is a problem because the majority of the platforms are such that this is not true, but the other is true for them. For example, GCSE, you have MemCMP included, and basically what you have there is it's logical. You go byte to byte and you start subtracting one from the other. So basically if one has 0 and the other has 255, then you get minus 255, which of course will be outside, will fall out of this. But will it cause a problem? No, it will not. If it goes the other way around, so you have the 255 in the bottom, or then you can generate plus 225 and you will be outside. You will be beyond the minus of this range. But this will not be true. And the first one where this will be true is a minus 256 and plus 256, because you have to go far enough from 0 in order to actually get back to the same place. So it's a bit like Wizard of Oz. If you go out on the left, you have to be coming in on the right. Well, that UB key will be a gift later on. Why was it unexplored for so long, despite the fact that statistical analysis shows it? Because this is not what they were looking for. They were looking for vulnerabilities and not weaknesses. The first time when a MemCMP comes out that optimizes the way the C standard author wanted it, so it will be subtracting several bytes from one another. That means that the prefix, the minus or plus, will be true, but the numbers that will be generated will be larger. Until this is the case, this will not be a vulnerability, it will be only a problem. For a long time it was a problem. Then you had all these optimized MCMPs appearing, and it became a vulnerability, but not large enough for anyone to start thinking. I'm sure several hundreds of people read this code. This file already had a similar vulnerability in 2004, but it was much more difficult to exploit. I'm sure a lot of people are reading this file, and they were not looking for what they were they did not find what they were not looking for it. Reading the code and of course being on the appropriate platform. So I think this is the major reason, and what I talked about is the fact that we cannot exploit vulnerabilities does not mean that no one can. So much for research. And then the other important topic is audit, code audit, which basically differentiates a white box test from a black box test. It basically is different from the black box test, is basically how it works with how it approaches trust. A black box test can basically build confidence, trust. I go to a company, give me an IP address, and I can break in. I have built trust. I go there, I said, I will give me the code, and perhaps I'll find something that is perhaps not so. So that is the big, actually big advantage of black box, and we do exploit this, we do abuse this. That is why black box, even in application testing, is still there. The focus, however, is perhaps, it is, in terms of focus, code audit is much better. What is it that we want to deal with? Is it security vulnerabilities? Is it transboundaries? There's much stronger feedback. If I read the code and find a vulnerability, then I will see the background much easier. I can hand it over to developers and I give much better advice on how it should be improved. And then black box is better. It's basically how we attack, we simulate an attacker. Usually we don't give the source because the attacker doesn't have the source. Why should you need it? We want to simulate an attack. What kind of attack can black box simulate? Someone who is prepared enough, but of course has only moderate or medium motivation. We don't have too much time. I only have time that they are paying, whereas low-paid university student on the 13th floor of the dorm, they have endless time if they are committed. There's different types of vulnerabilities that you can discover. I'll be showing you examples later on. In terms of coverage, again, of the application, black box is stronger because black box is a behavior-based thing. You actually study how the application behaves, and through its external surface we can actually, if we look at the coverage, we can run quite a lot of code, whereas in the other case you are a bit slower. Big question is, what happens if black box finds the source? Then we are in deep, big trouble. Everyone who wrote it, all those who are operating the system, this really is, and even the pen tester is in trouble because no one will be paying him to read all that. Based on all this, we have to do the white box test. So we are using web box type tools, and we actually also read the code. Because we don't have all the time to read every single code during an audit, we have to focus ourselves. What we focus on is predominantly dependent on what the customer wants. And if they don't know, we will probably help them. But in many cases, logically, one would think that they would be wanting us to find the most critical vulnerabilities. But in most of the cases, perhaps we have to go for the easy to find ones. Of course, it's not very cool, but perhaps it's much gives a better return on the investment by the customer. An important example, perhaps, is that you can't really tell what really will add to security or to the sense of security. This is a black box example, but I think it's also good here. Once we were auditing the web page of an insurance company, and there was this web shop where you could buy lower level insurances. What happened was, we were talking with the managing director, and we said, what are you afraid of? What is the business environment like? What kind of attackers can you expect? And he said, and they had this web shop in there where they were selling. We came with the concept that, okay, to buy free of charge in a web shop, that's the cool thing to do. And he said, I don't care. He said, I don't care if anyone is able to buy insurance free of charge. We'll find out at the end of the month. And anyway, what he's interested in is private data of customers and clients. And practically, of course, he got a report in which he had all the private data of the customers. A report showed that we were able to do that. There's a thing called the threat model. I think there will be a complete presentation on this. This actually helps us to see what is worth dealing with. We had 30 minutes with that managing director. If you don't have too much time, this is a good method. You find somebody at the company who is knowledgeable about the business and you try to find out what is important. If you have more time, you can actually commit yourself to it more. Methods of code audit. Classical Fagan type of things are good if you are actually developing a lunar rover or a nuclear plant, but it's not really the case for us. What is more like is we have time, we have to read the code, and we really want to find as many problems as possible. And in these cases, it is worth to relying on development support. You can ask the developers, here's a development environment, and it's good that I read the code, but nowadays these can be very complicated. It's not, you just don't read everything and you understand it. Life is a bit more difficult than that. And if you have even less time, then perhaps the most efficient thing is if you sit down face to face with the developer in front of a computer, or you sit around the table and you discuss the code. You read it together, they help you explain, they tell you why. We ask all sorts of stupid questions, and we say this should not be this way, it should be changed, and that is an SQL injection there. This really is almost like equivalent to a security training. A developer who actually participates in this will learn on their own code what important things are. It's much better, much more hands-on than just any classroom training. You can, of course, do code review completely automated. It does happen. It does have a use to it. How do we read the code? Very short, briefly. We have to understand the code, and that is really quite complicated. So we can read control flow sensitive, and experienced auditors say this is the most purposeful, but they will also read the two other. They say, I've started reading somewhere and I get to this place very fast where we find, let's say, a call to a graph, but we don't know what it is. Do we go and start to understand or not? If we do, that is control flow sensitive, and if not, it is the opposite. The other is the data flow sensitive. When the part that we are reading, there's a parameter, that's some sort of an input. Of course, that is what we'll be looking for, is something coming from the user or coming directly, and we try to follow that. But we're only going into the branches where it will appear. These, of course, naturally have to be combined. What are our starting points? The input, which is very important. grep is still very useful today. Static analyzers. And of course, we have a concrete idea in terms of, let's say, we have to be studying security functionality, etc. We have to be looking for complete modules where we just read the whole file. What was quite evident earlier, that we're looking for vulnerabilities. In code audit, we're not looking for vulnerabilities. I think we're not, because it's very difficult to prove that these can be exploited. And there's a whole lot of problems that are problems, we have to patch them, and they are potentially exploitable, but we are not doing a code review so that anything I read next week, next week will be exploited. However, at the same time, if we underline everything with red for every small problem, it will be the same as the static analyzer, that we have so many reports that it's difficult to manage. So I think there's a golden middle path that we have to choose. The first example. It's evidently there is an XML injection, because the way it is compiled, it links them with a plus. And that is what's coming from the user. That is a cookie of the user. This token is generated from the session cookie. It's an authorization module. So a web application actually addresses it, gives the user session cookie, it packages it, it adds to it in XML what the user wants to do, and it sends it to a background system that will decide if the user can do this or not. But because it was done this way, if I compile a session cookie that has such XMLs like what you have here behind, then I can just force it to send another resource, the resource that I want to be dealing with. I want to transfer money. Then the resource ID would be my bank account or would be the actual operation. And I can force it to actually compose an XML that has a completely different meaning, something that has a that I am authorized to do. And all I had to do was to just use my valid cookie. I have a valid cookie to actually add such XMLs behind it. Whether this is exploitable or not, well, we don't really know, because I was thinking like what I said, no, you cannot exploit it. I read how this is actually parsed onto the server, and I said you can't really exploit it. But because I came for this presentation, I spent some time thinking, yes, you can. Now I'm on the opinion that this is definitely something you can exploit. This 15 minutes would have been wasted. For a code audit, you should not spend the 15 minutes. You see this, underline it with red and just go on. You cannot have such a thing in any code. I don't know how I am on time. I go on.
Now, this example is actually on the paper that you have, because I'm going to have a workshop with a similar title, and there we'll be able to discuss that, because it's quite difficult to find that with traditional methods. So if you're in a position to tell all the details, then you're going to get the rest of it. Now, it's worth to come to the workshop, because it's not going to be that complicated. Now, the third direction is when we try to ensure the quality, that is quality assurance, but in such a way that we would like to focus on improving security. So make the code as such that the security would be enhanced. Now, how do we do this? Now, as we saw it in case of combing, since we have code review activity, regular code review, we actually read all the codes before we put it in, because this is going to ensure good quality. But if we prepare the developers about security, so we talk about the vulnerabilities, and you know, everyone knows, everyone bears it in mind that you need to focus on that, then automatically that is going to be transformed into a security code review. This is about developing security culture. So whenever we find an exposure, rather a vulnerability, which is written weakness here, but anyway, so you find the vulnerability, and there's always vulnerability in it, however smart our developers are. It's not a problem. The problem is not if it's in the code. The problem if it remains there. So you have to find it during the review. Otherwise, it will be like, come on, why are you always upon me? But, you know, the fact that we teach the developers what security is, they are not going to be professional. They're not going to find each and every vulnerability or weakness, because that's not their job. So we need to send the high-risk or the critical applications or critical codes to security review as well. And then we are going to have data and metrics. And we can, of course, for example, check how many lines we read in an hour, LOC per hour. If this is over 400, then we're in trouble. It should not go beyond 400, because then we read a lot, or we read too fast, and we won't find it. So beyond 400, it is quite difficult. Now, how many weaknesses or vulnerabilities we find per hour? So this is the detection rate, detection per hour, and detect the density. So this tells a lot about the quality of the code, and then this is where static analysis comes into the picture. So anything that was not really usable before, but here it becomes a very powerful tool. So when I start reading the code, and I have certain bad habits die hard, like I don't use the types very well, but if we just run the static analysis, then this will find it. And if it finds 5 instances, then of course I'm going to be unhappy, but I will just correct it all 5 places. And when I know that someone is going to run that in a month's time or tomorrow, I'm not going to write that again. So it will also teach me, it will also educate me how to program, how to develop well. So static analysis is a very powerful tool in this respect. But you have to do it in time, in due course, otherwise you will have so many hits, so many detections that it will not be usable. And then it will also talk about how many weaknesses or vulnerabilities you have, or how many errors you have of a certain kind. And of course, if you have 5,000 instances, then you cannot simply correct it. You just need to redo the whole thing. And of course, we need to know how a secure coding is done. So you have to have a secure coding codex and review checklist. And this cannot be adopted as it is. You always need to adapt it. So you need to employ an expert who can adapt it to your own field and can filter out or single out what the important things are in this respect. Now there's another example here. And we are not going to go into details. This is a 0 day from the summer. This is a Java code. And this is an app. And an app, with the help of this code, was able to load in something that it was not supposed to load. Now, why? It doesn't matter. What matters, because it's quite difficult why, but what matters is that you should not write things like this. It is here. This is the root cause of the problem. But it is a developer would not necessarily single this out. But in the Oracle code, it is written black and white why you cannot read this in an Oracle in a Java code in a plastic class, because then even if it's a code from an app, this is going to be loaded. So this is the problem here. We try to load the class as it has to be loaded, and then when it turns out that the person who wants to load it doesn't have the right to do so, then we are going to find an alternative method, and it will be loaded differently because probably this didn't work in Internet Explorer, and then the developer wanted to patch the problem and then choose an alternative way to load the class, and it really is loaded even if it's not supposed to be loaded. Now my other example, again the same thing. Here there is no vulnerability because this is a business app. We don't know what the problem is. We just know that this is something that cannot be done. This is a experiment, and this word experiment does not go together with security. We do not make experiments. There was a Java developer, and he wanted to make his life more exciting, and what he did. This is from Clued, after a book from Clued. He was a very well-known figure in development, in modular programming. He was also a lecturer thereof. Probably he was the one inventing it. So we write a huge file, and then that is going to generate the sources, and then we use a tool because which is only used by that person, and no one else understands this. Why? Because this was a separate part of this project, which is called crypto. Why? This is a cryptographic library or folder, and the cryptographic part was assigned to a cryptographic tool which no one else understood. And this is why Microsoft says you can only use tools that you know very well. You cannot use the tool before having approved the tool and approved it for the task. And then, actually, we are done. I don't know. Yeah, time is up, so that's great. Should you have any questions? I'd be glad and delighted to answer such questions. Should that not be the case, thank you very much for your kind attention.